Hey guys, my name's Seena. I work at Chainlink Labs. I focus on emerging market product development um, and commercial strategy stuff. I've been working in crypto for 6 years. I started at a company called Earn.com, previously known as 21.co. We sold to Coinbase in early 2018, and I focus on new market development there. A lot of it was like basis retail institutional products, so like our OTC desk, Coinbase custody. But then I did some M&A stuff, so things like Coinbase Neutrino, which is now Coinbase Analytics, which is the AML solution that they have. And then we did Tagomi, and then Bison Trails, which is now Coinbase Cloud. And so did that for some time. And then I joined Sergey and the Chainlink guys back in late 2020, and I've been here ever since. So yeah, looking forward to talking today.
Cool, that sounds good. Hi everyone, so I'm Tom. I'm an engineer in the space. Originally worked at a place called Aztec Protocol, which is a ZK zero knowledge privacy protocol that's now building a really cool layer 2. You should go check them out. And now I work at a protocol called Fei, which is a over-collateralized stablecoin and part of a DAO called the Tribe DAO. Very interesting governance, DAOs, stablecoins, ZK stuff. And yeah, I think we're going to be talking about some DeFi dev stuff today. So yeah, I'm looking forward to it.
Nice, very cool. So hey everyone, this is Mirza. I head up the business team at Injective. Quick background, probably started in crypto in 2016, I would say, mainly while working at a firm called 2 Sigma, where I was on the ventures team, mainly looking into crypto. Did a couple cool deals, like very early DeFi 2.1 projects, or 1.0 projects, I guess, like UMA, etc. After that, ended up joining Injective in early 2020. Been here ever since. We're now a team of 40 people. Most of us are here in New York City. So yeah, excited to talk to you guys.
Hi, I'm Kai. I originally started with crypto back when I was too young and immature to really understand any of the implications of it. Wrote my own GPU miner after mining on a MacBook Air for a little while. And more recently, I've worked on a bunch of different DeFi protocols, mostly in the privacy space. And I'm currently protocol architect at RAILGUN. I think I might actually sit over there because the whole room is out this way. But
Sounds
what mics?
Yeah.
All right, so how do we kick this off?
Yeah, we could honestly chat about anything. You want to kick it off with oracles, or just generally dev tooling?
Yeah, we can start with oracles, then we'll go down from that. So our job really at Chainlink is to stay up. It's really one job. Our job is to have geo redundancy, resiliency in what we provide, and that's why DeFi has been able to depend on us to secure the back ends of these smart contracts consistently. But the needs have expanded, right? That was very binary. It's very level 1, right? We call it 0 to 1. Now we're looking at 1 to end. And a lot of this is now based around cross-chain hybrid smart contracts and how we can utilize the best of multiple different networks. Now, this requires us to stitch smart contract code at Genesis. And so the development and the toolkits that people are using now are much different, much different. And the way we were developing back in, let's say, 5 years ago is much different than how we develop now. It's a multi-chain world to a degree. You can see that with Aave v3. You can see that with some of the new applications that are coming out. And so our job has changed as well. Like we bring on, I was just telling these guys before, people know about us from price data, but that is absolutely not all that we do. We do all types of data sets. We have a team that focuses around carbon data. It can be CO2 levels, deforestation levels. This is powering a lot of different type of ESG-based DeFi applications. An example can be Toucan, or an example can be Regen Network. We're seeing work in insurance. And so it really comes back to getting developers up to speed. And so we've been doing more strategic hackathons, which we're excited to start announcing. We have SmartCon coming out in September. Make sure you guys can tune into that. It's based here in New York on the 3rd week. And so, yeah, a lot of it comes back to how can we give developers back the toolkits that can help them actually create these hybrid solutions at Genesis.
Yeah, that is very cool. Like, what kind of tool sets do you provide for people that are kind of integrating with Chainlink and trying to build with Chainlink and to make their job easier in testing some of these oracles and some of these multi-chain kind of things that you talked about?
I think to start, Foundry, right? We can talk about Foundry, right? We have our startup kit inside of that. And just
Foundry
being
is very cool. I love
exactly,
it. Yeah.
Right? Like a lot of these new applications that are being designed actually help, which is super new. Maybe you can talk about your experience as a Foundry.
Yeah, so for those of you in the audience, if you're builders, you might have come across Foundry before. So it's a smart contract development framework. It's really, really cool. It was a lot of the guys at Paradigm have kind of worked on it, and it's basically a framework where you can write your smart contract tests in Solidity. So like in previous kind of tool sets, you would sometimes write your contract in Solidity, and then you would test it in JavaScript or TypeScript. But there's always a bit of like cognitive dissonance when you do that. You're switching languages when you're testing, which you never want to do. And Foundry is a really cool new way to test your contracts in Solidity. So it helps so much. So yeah, that's really cool that you got some stuff in Foundry for developers.
Yeah, I guess something that I'm always interested in whenever someone mentions a cross-chain project is what does your testing setup look like? Because like if testing on a single chain, it's very easy to spin up a repeatable test environment because you just kind of spin up like a local EVM instance and throw a bunch of like transactions sequentially at it. But if you're testing cross-chain, you've got like all of the networking side of things that you need to think about and like message passing and having the two separate EVM instances. So like yeah, what does your testing setup look like?
It's really hard, and we're actually trying to bake it into a solution at Chainlink. We're calling it CCIP, also known as Crosschain Interoperability Protocol. It'll be an out-of-the-box solution that allows us to bridge not just tokens, but communications, triggers, smart contract triggers, cross-chain in an out-of-the-box way. Now, we're in the research development phase of it. We hope to have progress on it we can announce in the near term, but it's extremely difficult to do this at the security of what we needed to. We've seen basic hacks with just tokens and bridges. We don't need to get into specifics. If you guys want, we can. But it's hard. It's really hard. Chainlink, we operate as a security company. We operate to provide that 24/7 resiliency. We've never had any sort of outage or downtime, and so we're trying to translate that back into the bridge that we're designing. So developers like yourself can have a toolkit where they can depend on, because as you've just pointed out, there is really no option besides some sort of hack job between like a Chaos Labs and different other tools and different auditing tools, and you can go get fancy with it and you can incorporate ongoing smart contract monitoring solutions, but it'll never actually be enough until you build it out of the box and it's been tested and it runs on a decentralized network.
Yeah, I think I'm definitely very fortunate to not have had to touch any cross-chain stuff because Railgun's quite explicitly layer 1. But going forward, it's definitely something I'm gonna have to think about. Given that, like, even if you have a purely layer 1 DApp, and like if you're having any sort of interaction with other developers that want to build on top of whatever kind of base layer infrastructure you provide, you need to be able to think about, okay, well, like, how is my development toolkit going to work with XYZ other protocols? Probably the most like common thing to date has been like there's a bit of a split between I know Foundry is starting to gain momentum, which is going to throw another spanner in the works, but there's been a bit of a split between Hard Hat and Truffle, and Uniswap's kind of like local testing environment was set up for Truffle. So for a while you had to like kind of shoehorn it into Hard Hat if you had your testing environment in Hard Hat, and then there's a bunch of other projects going back the other way. So yeah, have you thought about like maybe common standard for for setting the stuff
No,
up?
that's something we think a lot about. And so on a high level, just as a background, Injective is an app-specific L1. So we're an L1 if you want to build things with an order book, like an exchange, prediction market, etc. And we're part of the Cosmos ecosystem. So one thing that's a bit different about it is they have Crosschain messaging protocol baked into the ecosystem as sort of like the table stakes. It's called IBC, inter blockchain communication. So essentially, anyone building with that SDK, you guys might know Terra from the past, but also guys like Osmosis, us, many others, Crypto.com, they all use it. So what makes it really easy for us is that is a common standard or framework that we're able to utilize to send assets across other Cosmos-based chains. The limitation, obviously, is you're restricted to that ecosystem, right? So when Injective wanted to interact with Ethereum, we had to build a native bridge. Cosmos has a native bridge called Gravity, so people have to create a new implementation of it to interact with Ethereum. As you guys might have guessed, like that creates new sort of idiosyncratic vulnerabilities in terms of security, which is probably another reason why you see a bridge get hacked every other week. And one interesting aspect of it is because there is no sort of collaboration between those teams. Like when you think about, oh, this Cosmos-based chain, like we want to connect with Ethereum, and then someone else within the Cosmos community might be doing the same thing but have a slightly different implementation, then a hacker is able to basically go and exploit the bridges using similar tactics, because even though there was good auditing, etc., they're able to use similar frameworks to attack that. Cosmos, fortunately, hasn't had any kind of attack like that, but you see that a lot with EVM chains. And if you look into how these hacks occurred, you'll often notice that the attack type is almost always very similar. So I noticed that with like the Harmony hack, and then also the wormhole hack. If you look into it, the type of sort of attack vector used was very similar. So I think not only do we need a common framework to make it easier for people to use these protocols, but it's just needed for security. You can't have like 5 devs work on a bridge and 5 disparate devs working on exactly the same thing, and there's no collaboration between them because they're basically starting this work from scratch and making the same errors.
Yeah, there's been quite a few like high-profile bridge hacks and vulnerabilities recently, and we were talking last night about why that is the case. Why does it seem at the moment why that bridge is, in particular, very hard to pull off? And we were talking about whether it's a question of lindiness and that they've not been around necessarily so long, or you had a really good explanation about zones of control, which would be quite interesting to talk about.
So I mean, I guess just the conversation over dinner last night. We essentially talked about like most applications in DeFi kind of just touch single zone of control. So what do I mean by zone of control? If you look at, say, Ethereum and the kind of like rollups that exist on Ethereum, the ultimate source of truth is the like block production coming from Ethereum miners, right? Doesn't matter if you're like on a particular rollup or if you're on the main chain. But when it comes to bridges, the ultimate, you don't have a single ultimate source of truth. You've got block production from multiple sets of miners or multiple sets of validators, and the amount of complexity that you end up introducing into a system in order to kind of deal with all of the edge cases that come out of that. How do you handle potential like reorgs on one chain when you know that like a reorg on one chain doesn't mean a reorg on the other one? How do you handle like a potential like failure in message passing where a message from one chain doesn't necessarily get to the other? And you don't always know because like you're again crossing multiple like when you're within a single chain, you can get guarantee that a message arrived because really it's just like Byzantine fault tolerance, right? Like you know that something happened for sure within the same chain because like you're working with the same set of facts. But when you're working with a different chain, right, like you don't know if that message has arrived because that's a different set of facts that validators and contracts in the other chain are working with. And so like the amount of complexity that you introduce into systems when you're developing bridges like this is enormous. And on top of that, like we talked earlier, I think you brought up the whole testing methodology, right? Like it's very difficult to test cross-chain applications, and testing cross-chain applications this complex, it's no wonder that bridge hacks happen this often.
So ideally, in a perfect world, what do you see? Like, do you see a solution that is designed for a specific cross? How do you know what network? There's no out of the box way, basically, if you think about it.
Yeah, I mean, I guess it really depends on the particular application behind each bridge, right? Like, token-specific bridge is going to have to take a very different approach to a general message passing bridge. And I'm not sure that a general message passing bridge is possible because arbitrary data.
Just one thing.
is-
What do you mean by general message passing bridge?
So general message passing, like
just
you
relays
could
byte
send
data.
any arbitrary call between a
Yeah.
contract from one chain to another.
Okay.
Doesn't
Right.
have to be tokens. It could be.
exists between protocols, right? Like within Polkadot or within Cosmos, but I guess there's not like a common standard across every.
Yeah.
chain. That's
Yeah,
fair.
like the thing is, like between like Cosmos and Polkadot, you kind of have, again, back to like zones of control. You have a fallback or a common source of truth that you can rely on between like with like Polkadot parachains or like Cosmos. You got your zones, and there is a fallback that you can rely on there, but you don't have the fallback when you're communicating between completely different chains. And it's I think like for token specific or token bridging use cases, or just purely token bridging use cases, you can probably get around it with because it's a lot easier to build like economic incentives around this. And so you might not be able to solve it from a technical perspective, but you might be able to solve it from a economic perspective. But it's very difficult to build economic incentives around a use case that, like just a wild card, whatever you want to send across, send your message.
Yeah, and I actually have like a very interesting story about this, like about general message passing in general, and like a potential vulnerability as well. So what a unique type of application that we also work on is derivatives in general, and what we use data feeds from oracles, and without naming the oracle, we were using an oracle that
You can say it. You can say it.
No, it's fine. So basically, it's not Chainlink. It's not Chainlink, unfortunately. So basically, do you guys remember a couple months ago there was this like weird hack within CMC CoinMarketCap where all the data was out of whack and it showed Bitcoin was worth like $1 trillion. So that oracle happened to reference that price feed, like the data points from CMC. So some of the derivatives launched on our protocol, the price feeds went completely out of whack. So people were getting liquidated, and it was just a whole another thing, right? So it's like, yes, on a low level, it's great that we were able to use an oracle and get the data feed through this like cross-chain general message passing bridge, whatever you want to call it. But it opens up new attack vectors due to like what you just mentioned, due to the lack of economic incentives, right? There's little to no economic incentive for people to pass like good messages versus like when you have actual assets flowing through a bridge, there's like more economic value, like inherently, right? That's pretty easy to understand. So that also becomes a question, like as this industry grows, as like obviously DeFi takes off, like more and more people start engaging with derivatives or like options, etc. What does that mean for types of message passing that don't have those economic guarantees? It's just an open question.
The only way I've seen it done is through like forced incentives that are tied to a service that people literally pay for. So an example could be FlightAware, which is like flight insurance. You pay for flight insurance, like we've all seen, and most of us say no. It's like if you lose your bag, and if your flight is emergency canceled, I don't know. Let's say you lose your bag, that payment settlement happens on chain, so it's actually triggered. So we actually build a Web3 adapter. We actually take an API endpoint from them that lets us know if a baggage has been lost, as an example. And if that baggage is lost, then we execute a payment. Now that payment lives on some private network like Aztec, which Tom hasn't told you he used to work for. But the idea is that these things are broken up in ways that people are forced to pay out. Another example is crop insurance. So Lemonade, we have a crop insurance use case and flood insurance use case. So we tie weather data, we tie the level of climate, tsunami data. We bring in hundreds of different data points in. And so the only way we've actually seen it done is when there's an incentive that has like a direct cost that people pay for, and there's a set amount of collateral set up basically that is released based off a smart contract trigger. Another one that we've seen is KYC through a ZK rollup, right? So if you want to, let's say RAILGUN wanted KYC, it's people have, they would actually send it through a ZKP to do it on chain. So it's done through a validator network as opposed to just a single database that tells you that Mirza is Mirza.
Very curious, just to jump in, like, how do you see in Chainlink the kind of usage growing between like price feeds and these other like kind of Oracle uses like crop insurance and things like that? Is that growing really quickly, or like how do you see the future looking?
Yeah, denominated in transaction count growth is happening mostly everywhere. Like volume stays relatively consistent. These net new data feeds, which we as a company, we do our best to grow the ecosystem. So we have to find the projects, bring on the correct data sources. So it's a little bit of a chicken and egg game. Yeah. And so we sort of ride the current when we see the wave start taking off. And so ESG is a very big popular one, for example. Insurance is another very popular one. And so when we see these, we pick it up. GameFi is becoming extremely popular, how we're looking at that, and certain data sets we're bringing on for those. And so to answer your question, we do see a pretty big spike initially, right, in usage. And then from there, people figure out what chains they want to live on and, where these use cases are supposed to be. And then you see more mass adoption happen. And that's where it hits more mainstream developers.
Yeah, that makes sense.
Yeah, I guess just on the like previous topic, what I'm really hearing here is, for sort of like more general use cases, you're really trying to identify on a case by case basis what the economic incentive or what the economic value for that particular use case is, and trying to over collateralize the actors in the system. So against that, like particular economic like value or what they could extract from it by exploiting it, which I mean, that's really difficult to scale.
Yeah, I mean, the Lemonade use case is on Avalanche, right? And so proprietary data like the PII, their information, their age, the price, the balance, all of that lives on the SE chain. But everything is done off the general Avalanche network. So you're basically running it off of that, right? You're depending on Avalanche being able to withstand that volume, right? So you're absolutely right, right? They're still pet projects.
You guys want to just go generally talk about smart contract deployment across different chains, how the dev tooling differs?
Yeah, I could talk about what it looks like on Ethereum, and then you guys are built on different chains, so we could look at some contrasting opinions. So I think anybody who's worked with Ethereum might have deployed a smart contract. Typical kind of process for that is you write your contract in Solidity, you then compile it with the compiler, and you get a lot of bytecode. And this bytecode then gets deployed and lives somewhere in the Ethereum blockchain. And we talked about some of the tools that you used to do this before. Foundry is a very common tool. Now they've got Foundry scripting where you can do this. Truffle, Hardhat, some of the very standard things. And then once it's deployed and out there, people typically kind of monitor the state of their smart contracts on Ethereum using things like OpenZeppelin Defender and or various tools to kind of query the state of what's going on. I'm very interested in how you deploy to things like Cosmos, because I personally haven't done that before, and what that kind of process looks like.
Yeah, I mean, I can describe it on a very, very high level because I'm not the actual person deploying the smart contracts. Within Cosmos itself, the main way you create smart contracts on the blockchain itself is with a language called Cosmosm. And Cosmosm is a Rust-based smart contract platform, which you might be familiar with if you have built on Solana or Polkadot, which also use Rust. So that's the main difference, right? That's the first difference, that, okay, it's not in Solidity. So what we often have to work with is most developers these days don't know Rust off the top of their head. Like some are very specialized, but most developers in crypto come in through Solidity. So that's the first challenge in terms of deploying contracts in general. So I think a major thing the Cosmos community has been working on is creating scripts for different languages. Like we created a module in Python, for example, to let more people be able to deploy contracts. But otherwise, the process itself is very similar. I would say the dev tooling on Cosmos is more nascent compared to Ethereum, obviously, especially when it comes to things like audits, etc. So, for example, if you build a smart contract on Ethereum, a great part of it, or any EVM chain, a great part of it is there's like hundreds of auditors, honestly, like whether it be a professional firm or that can do it. But with something, when you get so specific, like CosmWasm, right, which is a WASM-based language, it's like, okay, we have like 2 auditors to work with. So that's another challenge, right? So yes, in my opinion, CosmWasm is a much more sophisticated smart contract layer than just what EVM chains have, but it also comes with a lot of risk. Like you have less auditors, there's less like tooling available. It's much harder. There's less devs who are knowledgeable on this sector. So I think those are challenges everyone is facing, and I think the problem is not helped by the fact that a lot of new chains are actually coming out. Like you guys might know of like some new cool chains coming out, like Aptos. I don't know if you think it's cool or not, but they're using, for example, Move, right, which is like the language created at Facebook. So it's getting worse, in my opinion, not better in terms of composability, not from an asset perspective, but devs being able to build across platforms, right? Like let's say you were previously a builder on Ethereum, now you join a new project, now you have to learn a whole new language, start from scratch, and a lot of the tooling is different. I think that's what's keeping a lot of crypto behind as well in terms of innovation, because you constantly have to reset and start over every time something new comes out, because the new thing coming out wants to have like nothing to do with the old stuff, right? They're trying to build net new.
Yeah, and you're talking specifically about examples of network effects. I think there's such big network effects around languages. You get tooling built up, you get auditors that you can then rely on, you get other people developing best practice and things like that, for definite. Something that I am very excited about in the future, and it's a bit straying outside of the crypto world, but in AI, there are so many kind of now advances in various AI language models that can convert code in one language into code in a different language. And some of these things that you can see like GPT-3 doing, and there's a few other kind of code-specific models. I think that kind of stuff in the future could be really useful. If you've got some contract in one language, being able to immediately convert it over to something else could help, for definite. But yeah, languages are cool.
Yeah. At Injective, do you guys do anything to help bridge that gap for people? Like, I don't know, courses, or do you guys point them in a certain direction? Or, you know, if you want to encourage developers to do more on Tendermint-based chains, like where would you point them?
Yeah, so the WASM libraries are pretty extensive, actually. It's actually very easy to follow, just probably is a learning process of at least a couple days if you're pretty experienced. So I would point you to the WASM library, and the instruction toolkit is pretty easy to follow. And the cool part about learning WASM is once you learn it, you can deploy on any chain that utilizes anything related to Cosmos in many ways, right? So you'd be able to deploy on Cosmos itself. You'd be able to deploy on Osmosis, Injective, Secret Network, which you might know as Enigma from before. So it gives you flexibility in terms of that. It's not like you're learning a language like only for one chain. You're learning it for this entire ecosystem. So, and I think it's helped by the fact that a lot of popular projects are now migrating over to Cosmos, which is bringing more mindshare, and it just will ideally expand over time as well.
Yeah, I think like something I've sort of noticed is even so there is a reason behind this, and I guess we can get into it later. But you know, with EVM chains, like you can be fairly certain on what to expect, because you're not standardized around language, you're standardized around the actual execution environment itself. And so, like something that would run on, say, Ethereum would also run on Polygon. With minimal changes, if any, are actually required. At least from the Solidity side, I mean, I know there are some off-chain differences that need to be accounted for. But with WebAssembly, so WebAssembly is it's not like in itself. The spec isn't deterministic, and you need a deterministic spec in order for something to run on blockchains, because you need all of your nodes to execute the same transaction and arrive at the same result, right? And so every attempt at creating or every like different WebAssembly chain ends up modifying the WebAssembly spec slightly, right, in order to make it deterministic. But there's no standard around exactly what that modification should look like. And so every WebAssembly chain, even though you're writing in Rust across all of them, all end up having slightly different runtimes that you need to account for one. The interfaces and all tend to look very different. And so I think part of the reason that languages like Rust and all haven't taken off is if you're learning Solidity that will work on anywhere that Solidity runs, right? Whereas if you're learning Rust, you've got all these, like, Rust is a systems programming language, and it's what like large parts of Firefox is written in. It was designed by Mozilla for a lot of their like Firefox and like Firefox OS and a lot of their low-level code. So it's a very generalized language, and so there's a lot of different flavors of Rust that you can write. And it turns out that like the implementation differences between all of these different chains are large enough that the Rust that you learn in order to write on Near isn't necessarily the same sort of flavor of Rust that you'd write on, say, Solana or like Cosmos, because of those implementation differences. So I think that like that's probably the reason that Rust isn't seeing as big of a like, you know, adoption spike as like Solidity has.
Yeah. The other thing I'll mention is, like, as much as people in crypto talk about wanting to work with each other and collaborate, I think a lot of those differences are made because every single new chain that builds wants to have like its own ecosystem and be very different and separate. So maybe inherently that was a strategic decision on their end. I know for Solana it definitely was that they wanted to sort of build their own moat around their ecosystem. And I'm not saying anything bad about Solana, by the way. Like, I think every other chain is doing similar things. So I think the economic incentives for the actual project, because they want to be so different and so new, prevent the issue, like make the issues worse, right? Like it just exacerbates everything, because now you have you're incentivizing devs to learn something new, and then you're making it really hard, like a normal startup would want to, like in Web 2, that you're making it really hard for those devs or those users to go onto another ecosystem because it's so different. So yes, every single project on a marketing level talks about composability and cross chain and how they love working with everyone else, but I think the way that most chains are built is antithetical to that narrative.
Switching gears just very slightly, so I'm very interested in governance and DAOs and things, and I've only really kind of looked at governance on Ethereum. I'm very interested in what happens on other chains like Cosmos and Solana. Like, do people are DAOs getting built? Are they
Yes.
building kind of like optimistic governance things?
Yeah.
Are they like
No,
very
I
interested in
I
what
can
happens?
talk about this for days, actually. So I think Cosmos governance is actually quite beautiful. So essentially, how governance and security on Cosmos works is every single chain has its own set of validators. So let's say a great example is the following, right? The benefit of this is when Terra died, it didn't impact us in any way, and it didn't impact Cosmos, like because we have our own set of validators. The security is not shared. Some can argue that this makes building new things harder because Polkadot takes the different approach where it's like, okay, we have shared security, so many all the projects can build up and not have to recruit these validators. But for Cosmos, that's helpful, right? And governance within each chain within Cosmos is pretty similar in terms of you can write a proposal from a front end level. It looks pretty basic, just like you would on a form like Commonwealth, right? Like you just propose, and then every single chain probably has a different voting like process, because for example on Injective it takes 4 days for people to vote. So anyone who's a delegator or a token holder can vote, right? Some chains do 2 weeks, some chains do 2 days. So it really depends on the chain, but certain factors are exactly the same. So there's this thing called quorum that you need to reach. So 33% of all the delegators need to vote on a particular proposal for it to actually go on to the next phase, and 50% of those people, like plus one, so slightly more than 50% need to vote in a certain direction for it to get passed. So from that logic, it's pretty easy, right? Like that's how normal elections work. So yeah, I think the way Cosmos thought about it, it's actually quite unique, and it also is pretty much the same, other than like the voting, like how long you have to vote. It's pretty much the same across the Cosmos-based chains.
Yeah. I think because we're starting to like get pretty far along in terms of time. Is there anything in the audience that people would like to hear us talk about?
There's a hand.
Yeah, just curious. So, we're in kind of a bear market. Recently, we saw news of Injective with $40 million. It's quite impressive at this point. So, in general, I mean, how are you achieve that? What's the selling point to the VC at this point, first of all? And second of all, what's the where are you going to import those money for? What are you going to do in general?
Okay.
How to use those?
Thank you for that question.
What are the company secrets? Let's go.
Yeah. So I think like the way we thought about it was from a strategic decision. We wanted to be able to survive the bear market and also grow during the bear market, which is I think against what most protocols think. Like they probably want to slow down and like fire during the bear market. So that's one incentive for us wanting to do this raise. And I think a couple factors probably led to it. If you want to get really specific, I'm not trying to show any of these factors, but since you asked, so I think it was mainly based on two parameters. So one was Injective transactions were going off the charts. So we had processed almost 100 million to date. So right now it's 96, I think, which is for for perspective, more than many popular chains today, like Solana, etc. So I think many VCs saw that factor. And then the second part was the protocol was built with these modules in mind, right? So Injective is very specific for building DeFi applications, right? So you can think of it like the marketing way of saying it would be like a WordPress for DeFi. So people could essentially take the order book module we built or the derivatives module and build their own app within a week, right? Whereas on other chains, you'd have to build those modules from scratch. And many of those apps, the exchanges deployed on Injective had generated something like $7 billion. So I think these two stats helped the VCs reach out to us, and we wanted to get a deal done because we saw our sentiment internally was the market's going to get worse. So we want to be able to grow in this market. So I think that's probably what led to it. I think my recommendation is like, it was mainly regarding stats.
What are you going to use that money for the next?
I guess like on a high level, like what any VC would use money for, right? Like, or any project, like increasing liquidity, growing the team. Yeah.
I think I saw a hand at the back right over there. Yeah. Do you want to go for it?
Yeah. So I'm definitely not a builder myself, but I'd love to hear from people who are. So like, I guess the question is kind of around like, in crypto, one of the coolest things you could do is like verify that a smart contract is going to do what you think it's going to do. I.e., like when I go to Uniswap, I can go and verify the code, and that it's going to do my USDT to my favorite shitcoin swap the way I expect. And I'm wondering if you guys can like provide a little bit of color as builders, like how plebeians like me can like go and like verify and do the appropriate due diligence in DeFi associated with like using a protocol, like and like how can I like as an idiot verify that a contract is going to do what I think it's going to do? Because it seems to be like there's a lot of like so for example, like Curve recently got wrecked on a front end issue, these kind of things. So like I wonder if you guys have any like top tips for plebs not trying to get wrecked.
Yeah, I guess there's a few strands to that. So I guess like if you're not technical, you're not. It's not feasible to kind of go through a smart contract and read it and kind of verify it. So like, the first thing to do is probably like social clues. As soon as like vulnerabilities are discovered, they are quite quickly kind of broadcast across Twitter and various spaces. There's warnings put out, and so yeah. If you're interacting with something, I would always kind of like do a quick scan and check that there's no kind of like red flag anywhere. I think going forward, I think wallets actually have a big role to play here. So I think wallets, when you are kind of going to be interacting with a contract, I think there's a lot of work that could be done there to kind of early flag like this contract looks suspicious. Maybe no other party has kind of sent funds here in a long time, or maybe it doesn't conform to an expected interface, something like that. And so I think there's like a lot of kind of technical improvements that could be made around that user interface to kind of help people that aren't reading smart contract code be confident in what they're doing. And then the last piece I would guess is like stick to well-known kind of like areas. I think going off the beaten track can definitely be tricky, but it is hard to independently verify if you're not reading the code. Does anybody have any further suggestions?
I think a lot of the hacks, more recently at least, are starting to drift away from being like Web3 kind of hacks where like a particular contract gets exploited or something, and more towards Web2 hacks. So particular bit of infrastructure or something was compromised. So I think the first sort of action that you can probably take is making sure that you have best Web2 practice, Web2 security practices as well, right? Like you're verifying the URL before you go to something.
Yeah.
You're not like interacting with things like over like plain HTTP rather than HTTPS. All of that sort of stuff. Going in a bit deeper, there's like seed management and all, right? Hardware wallets are getting to be very, very important. We saw a fairly high-profile hack recently where inadvertently the software was sending the seed phrase as part of the debug logs to to like a crash analytics server, right? And like anyone that had access to the crash analytics dashboard were able to see the seed phrases sitting there in plain text. No comment. But yeah, so there's like keeping sensitive key material secure. So using a hardware wallet for one is probably like the most simple way to like significantly increase your security level. Is pretty important, and I think the rest of it really comes down to as you were saying, like kind of wallet design, right? There's a fairly well-known problem or well talked about problem in Ethereum called like the blind signing problem, and this is sort of was more prevalent with early hardware wallet design, and it still is to a point, right? Because the screen on a hardware wallet is like that big. You barely see anything on it. So you're kind of, especially earlier on, you're kind of relying, if you're going on an ETH transaction, right? You're relying that on the fact that, hey, the transaction that I'm signing on my hardware wallet is what I'm seeing on my computer screen, right? And if your computer's compromised and it's sending the wrong transaction to your hardware wallet, even though you've got a hardware wallet, it doesn't mean anything. So there's been a move to like there's a couple of hardware wallet manufacturers that have started building like larger screen devices for one, and there's even with like the older like small screen hardware wallets, those are starting to have like a kind of like multi-step verification where you can see, okay, well, this is the address that it's interacting with, this is the actual function that it's calling, and these are the parameters that are being passed to it. So trying to like source a hardware wallet that has good like anti-blind signing properties is probably a good idea as well. So let's say you were to interact with Curve a lot, right? I can go and kind of like go through like social queues, maybe like look at the Telegram or something and see if they've got like the contract address pinned there. Maybe verify that in a few different places, right? So I know this is definitely the right contract address. And then when I go to like interact with my dApp, I can check on my hardware wallet. Okay, well, it says that I'm signing it to this contract address. Does it match the Curve contract address? Yes, no, good. I'm doing a trade. Is the like function that it's calling, is that the swap function, or is it withdraw all LP and it's calling withdraw all LP with someone else's address in it, right? Like there's there are sort of like methods to verify, at least with more well-known dApps, that the actions that you think these like front ends are taking actually are the actions that it's going to be that are going to be taken. But I think that's something that's up to wallet manufacturers and like hardware wallet manufacturers and like wallet developers to try and make more widespread.
Yeah, being able to like kind of verify function signatures definitely requires some technical literacy. I really like smart contract wallet based providers. So like without shilling them. Argent is a really cool smart contract wallet. And it's got kind of modules on it where it's got like built-in like functionality where you can like swap assets and you can like do all sorts of stuff. And then you're like, I would say like pretty good because like you've got this kind of like closed ecosystem of like modules that have been built on, and you kind of almost like I don't know if there's the right phrasing, but outsourcing the security onto like experts that have kind of built this kind of stuff. So I'm quite a big fan of these smart contract wallet based things. I've got these pre-existing integrations. Obviously, they might not have everything, and so that's when you have to start moving on to some of these methods that you talk about. Yeah, I think they're quite a good step forward for this kind of stuff.
Yeah, although I don't think you really need the smart contract wallet. Really, that sort of thing I think comes down to if you want a multi-sig or a kind of like social recovery stuff that Argent does.
Yeah.
I think it's still possible to kind of have these like built into the wallet modules in just a traditional like EOA account as well.
Yeah, you could definitely build that. Do we have any more questions?
Why is MetaMask still so bad after so long?
I actually have a thought. I was debating this with a friend recently. I think it's because there's no incentive for them to innovate, right? Because they've achieved like such good network effects that there's probably like 10 wallets that I would argue are better than MetaMask for Ethereum sort of dApps, but it's the only one that's highly adopted. So if you think about a new wallet that comes out, let's call it X wallet, even I myself will still probably not migrate over because it requires me to take all my seed phrases, put it onto that new wallet to import over, which creates a lot of new security vulnerabilities that I don't want to do that. So even though MetaMask's not the best, I would rather just stay here because they have all my seed phrases, like it's connected with my ledger, let's say, and even if I wanted to import it to something else, like it would just require me to expose some private keys I may not want to, etc. So I think that's probably deterring a lot of people from switching over. The switching costs are just too high, and also the lack of compatibility. So almost every dApp will support MetaMask, right? But they're not going to support whatever new wallet comes out. So that makes it really hard for, even if I were to want to switch over to another wallet, like I can't use any app. So what's the point of me switching over? So yeah.
I just did exactly that. I switched everything over to Trust Wallet.
Oh,
It's like I could not stand using it anymore. It's so bad.
yeah.
How long did it take you, Harrison?
Not long. Only like whatever, an hour. Writing stuff down. And,
It's just so funny. Like I always ask people, like, how often do you switch your bank? Like, have you ever switched your bank? It's kind of the same concept, but it's actually more lift. Sending a wire is not hard. It's, a routing, account number, and you gotta break it up in your daily limits. But seed phrases are actually super sensitive, so there might be a service in the future that helps with this, but for now, it's just too sensitive.
Yeah, I think there's a compatibility aspect of it. For one, I think that makes it pretty difficult because like the Web3 provider standard is fairly well fleshed out, but even though there's like a wide standard, there's still a bunch of like quirks with the way that each individual wallet implements their Web3 provider. I know like Frame does a pretty good job of like actually emulating MetaMask behavior and being pretty compatible with MetaMask. But like most replacement wallets tend to be not quite compatible, and then it'll like break dApps in unexpected ways. People just end up using MetaMask. And then I think so. Yeah, it's difficult for new wallets to break into the space, which means that there's not much competition for MetaMask. And then also, as far as like the role of MetaMask, slightly hot take here, but it's owned by consensus. Most of the services and all that they end up integrating into MetaMask are also consensus-owned businesses. Like, yeah. I'll leave it at that.
I think we've got about 10 minutes left, so any more questions? Yep, go for it.
Is there like a merit to having a pause function, like guarding against like your business logic on your contracts?
Yeah.
Especially when it comes to like DeFi
Yeah, in general, like pause functionality is a very good thing to have, especially in the early stages of a smart contract based protocol. There's kind of like a path that you go through when you're building a protocol where you start out with, you launch the first minimal version of it. It's kind of got some controls on it. It's maybe got some admin functionality. Maybe an admin can pause certain key functions if something's going wrong. Because when you first launch something, like even if it's been audited, there's always a chance that you're going to have security issues, that you're going to have to like maybe fix something, upgrade something. And then over time, as like a protocol and set of smart contracts get more and more battle tested and more kind of Lindy, then you look for ways to kind of remove some of these kind of almost like get out of jail for free functionality. And eventually the end state is like an immutable set of smart contracts that can't be changed. So definitely pause functionality is really, really useful. As soon as it helps limit the damage of something going wrong and kind of shut down kind of attack vectors. So yeah, for anyone who's writing smart contracts, yeah, you probably know this. OpenZeppelin's got a really, really nice pausable library that you can import and use. Yeah, definitely.
If you think about it though, like when you're trying to build a properly decentralized protocol, many people have argued that Solana does this all the time, right? They pause their chain to prevent against whatever attack or whatever congestion issue they might be having, and that's one of the main reasons people argue that Solana is not that decentralized, because they can pause it at any time. Like, so from a developer perspective, having a pause functionality is good, but do you think from like an ethos perspective of what crypto should be, it's actually like maybe not that good?
Yeah, so I think there's definitely a big distinction between being able to pause a single smart contract that does a single function and like does a particular thing versus pausing an entire chain, an entire ecosystem. There's a very big kind of different set of things that you've got to weigh up there, I think. Yeah, for a smart contract case where you're starting out and like this contract's got loads of funds in it, maybe it's not been around that long, makes a lot of sense. But yeah, you eventually want to end up in this state where you talk about where it's fully decentralized, there's no admin controls, and you can get to that point with some level of lindiness and battle tested contracts.
Yeah, I think it comes down to like the level of damage and the level of
Yeah, definitely. Yeah.
the level of like social consensus that needs to be reached in order for a particular thing, or social consensus outside of the immediate user base of the app that needs to be reached in order for something to change. If it turns out that like users end up not happy with a particular app, right? And so we saw this with Ethereum, with the like Ethereum Classic ETH like DAO hack fork, where like a hard fork was made to essentially take ether from where it had been like moved out from a particular contract and move it back to people that had donated to that particular contract. So for a chain, right, like chain level stuff, if a hack occurs that affects the entire chain, then essentially the level of social consensus that needs to be reached in comparison to the number of people, or the number of people that need to be in social consensus, is roughly equal to the number of people that are actually like affected by the hack. Whereas if you have a smart contract, there's no way you're going to hard fork an entire chain just because one contract got hacked. And so the way that you need to treat the like your contingency measures for like unwanted outcomes of like a smart contract and an entire chain is going to be very different,
Radically different.
Yeah, I think like I'm a fan of having a pause function, at least in the like earlier stages of a project, because it seems to like hit the right kind of middle ground where you don't want to have just straight up admin keys, right? Because that's just like you've got no oversight and people can do whatever. Admin key gets compromised and you're done. Whereas like a pause function implemented in a way that has I think you need like some recourse in the case that it gets abused, right? So whether that be like, hey, if someone pauses it, you can have like the regular governance system that, because most of the time the purpose of having these like contingency measures is because it takes time to do a proper like governance proposal and everything and put that
days,
through,
maybe a week.
whereas like in the case of a hack, you want to be acting quickly, right? So whether that recourse ends up being, hey, maybe we like take this power away through a regular governance system, and so you've got that recourse there, or through another method, right? So you like, I think you need recourse, and I think you need to implement the pause functionality in a way that, depending on your use case, isn't going to be like exploitable for economic gain. So if I had a particular trade that was like high value, that might like be beneficial for me to like, you know, front run, but I can't do it yet. So maybe I pause the function, pause the contract, like, you know, prep all my front run stuff, unpause it, like let the thing go through, front run it, like I front run it, and then like pause it afterwards. So I can like back run it or whatever. Like I don't know. There's gonna be like a million ways that could possibly be abused. So, you know, making sure that you're implementing it in a way. I think like pause only with unpause by governance vote is probably the right way there. But yeah, I think implementing it in the right scope and having proper recourse is probably the right balance, at least in the early days.
Yeah, so what works well there, I think, is, yeah, you have a DAO, your normal governance stuff, and then some people call it the concepts of a guardian, which is like an emergency kind of safety focused kind of like admin entity that can pause things. And quite often these guardians will just have very limited scope and very limited roles, and they can just like kind of pause key contracts, and then the system gets going again through governance. Yeah, delineating it out like that, I think, makes quite a lot of sense. So yeah, pausing is yeah, very useful in the early stages. Any more questions, or are we're getting close?
We're good.
I think we're good.
Yeah.
Any closing?
Yeah.
Thanks for your time, guys. Appreciate it.
Appreciate it. Yeah. Thank you.
Thanks.